Today we want to talk about like a blueprint framework to create reliable AI within the organization. I think that's, as Mark mentioned, frameworks is the way to go. And we have to focus and change our mind how we have treated data or data assets before to make it more reliable, because for the new area that is in front of us, that's the AI and agent area. What we need is to take a different route and approach for managing your data assets in a different way. But let's start here with well, that's the two of us, though, Inga and me. Um, and so everyone knows the value of data. The question is how to realize the value of data in an enterprise context. I think we all have seen like these sentences, yeah, data is the new oil and so on. Um, but sometimes then they have like POCs running the company and the POCs turning out, yeah, they're working in small cases, but not in big cases. Or, well, we have done many POCs in the past, basically, where it's like, oh, we had great ideas, and the problem was the data was not accessible for us as in a POC given time frame. And so we're spending more time on getting access and permission to get the data instead of like working with the data, which is usually not a thing you want to do in when you do a POC that is like set for 3 to 6 months to show some value. You don't want to spend 3 to 4 months getting permission on data. So what we came up with, basically, we want to change your thinking, and therefore we want to start with a little problem statement. Well, you have basically one of the senior managers is asking how many customers did we serve last quarter? And the problem is then here you get multiple answers. You get like sales department gives you 100,000, the finance says like we have 40,000 customers served, and this customer support says like it's only worth 70,000. So the question is now, who of them is right? Who is the right answer? And to solve these issues in the past, and I don't know why my computer just jumped, um, is well, we try to harmonize data in a single place to build a golden record, a single point of truth. So, and this is how we really started it. But nowadays, can you give you already the answer? Everyone is right in this picture here. It's only the context that matters. It's basically from sales perspective, um, they have a different definition. So there's no right or wrong. Everyone is right in that case. The question is no, in which context is this question raised? So let's start off with the initial problem, how we came to the problem that we have nowadays. So we have to understand the history of data, basically. And it all started basically with data warehouses. Data warehouses were built in the 90s, 70s, 60s, 80s, the Oracles and Teradata's by that time. And they all started basically having multiple smaller systems that were built on relation databases, and they tried to aggregate all this data from different places into one single relational data store. That's called the data warehouse. The data warehouse then is basically the single point of truth where you could do all the reporting for all these overlying management functions that doing multiple reporting, financial reports, and so on, and strategy-wise. But after in the early 2000s, all the social media came up basically, and now we are sharing a lot of pictures and text and movies and all this unstructured or polystructured data, and that needed to be stored. And the data warehouse wasn't really made for multi-structured, polystructured data, and therefore we came up with the data lake concept. And the data lake concept is basically a place which is easy to scale so that it can store a lot of terabytes and petabytes and exabytes and whatever. And then also, besides the data source, it can also really easily digest these unstructured, polystructured data, the images and videos and so on. So that now you have, again, combining many data sources into one big data lake source. And I think probably most of you've heard about the term data swamp, because if you don't manage a data lake pretty well and put all the garbage into a lake, this turns over time into a swamp. So managing a data lake is really a tough thing that you really have to be uh, restrictive and not accepting everything, and try to really organize and be really structured in the process of managing data in a data lake. Also, speaking of data governance and security, can I store these images with my financial data and so on? Can I merge this? There are so many tricky questions hidden in there. And therefore, there are two approaches that were followed after the data lake initiative. It's basically the data fabric and the data mesh approach. So the data fabric is more or less basically taking individual data sources and put on top of it like a fabric, which has some bells going into the fabric, and then out of the fabric there come smaller boxes with a unified access pattern that basically go to the fabric and get the parcel that you need from the single bell that has structured all the data with great metadata, with great labels on the boxes. You know who's going in the fabric in and out, so you have great access management. But it's like a central place again, centralization. And there's another approach, like a decentralized approach. That's the data mesh part. So basically, data mesh, thinking of like, oh well, we have scaled pretty well in in terabytes in technology and in tooling, but the thing that we really not really scaled well was the people approach. So we know technology, people and process is a big challenge to scale. Technology is easy to scale. And data mesh said basically we will have a distributed approach and building multiple individual nodes here. Um, well, I have a slide for that. I don't know if it's about audio. So let's focus on data mesh. So data mesh is a decentralized, so technical approach in managing and assessing analytic data at scale. And this is a statement by Samak Degani. She initially wrote that in a blog post at ThoughtWorks. And I think a lot of people have really catched up on this thinking like really, okay, let's put what is socio-technical approach, basically scaling human and organizations along with the technology. And she also said, like, it's not about technology here, it's about really about getting people, getting the knowledge and the domains. I always try to say it's like if you're a software engineer, you know domain-driven design. It's basically applying domain-driven design on data. That's my personal summary here to make it easier to remember for me. Well, data mesh is based on four principles. So there's the domain ownership. So it's kind of clear there must be an organization behind data. Data is a valuable asset in your organization. And if the data you store doesn't bring any value add, it's always a question, why should you store it and spending money on it for having it? It's as simple as it is. So we always need to someone who can explain you in a business term why the data is useful. And if somebody said this data is useful, there is a reason why I should deal or treat that data with more caution, deal it more like as a product. So data as a product, so there is not always the thinking of like I wrap all my data and make it publicly available on a marketplace for everyone outside. No, that's not the thing. We try here to make is a more product thinking approach. Basically, you treat your internal data that you're not also sharing outside of your organization or even outside your domain, deal it as a some sort of a product. Basically, a product that has nice labeling on top of it, it's a good description. There's you have a list of ingredients probably. There's a good manual to it. There's a well documentation. Who's the contact people behind it? What is security and other governance attributes on top of it? That's basically product thinking. And then if you have something that you have wrapped as some sort of a product, that would be great if you have a self-service data platform that helps you to build data products with certain enterprise standards. So within your organization, there should be standards what a product is, and then basically a platform, one single tool where it's like, okay, now I can put it helps me hopefully to build that product and also make this product somehow visible to others in the domain. And since everyone is using the same concepts in mind, it's easy to have a platform at the center that can be used by everyone in the single data platform team that doesn't belong to any organization. It's completely independent. But also the each business unit has its own independence by having their own technology components. So basically, a data product can build for one company in, let's say, MySQL, and the other one could use Postgres, and the third one could use MongoDB, and the fourth one could do, I don't know, an S3 bucket, for example. Still, if they're all following the same concept of a data product, it doesn't matter. The technology is completely independent because for some business units, they are really depending on um, flexibility in storage. So MongoDB would be a great thing. Others need like I have to be have everything to be stored relational. Therefore, they're going Postgres. This is completely a business decision. It's not something you can do centrally. It's always based on the needs of the business unit. And if you have done on top of that, managing products have a life cycle, there will be some sort of federated governance, federated computational governance. Well, the governance means basically you have in the enterprise, there might be a small single unit that's defining certain standards, how products are shaped, what are the descriptions, probably what is the self-service data platform. How should an organization look like that is running in each individual business unit? Should be there like governance platforms or boards? Like there could be data product office boards where all the data product officers from different business units come together, talk about problems and standards. So there's a small team that is managing these standards. And then in each individual business domain, you have an individual business unit data governance part. And these governance parts are in sync by this central unit. So therefore, it's like a federated state. Here in Germany, we have also a federation. We have Germany as the country, and then we have 16 federal states. So Germany is divided again in 16 smaller states, and these states follow under the German law, and they work with each other independently somehow and have local decisions and central decisions. And the same concept is applied then on the data level. So that's basically data mesh. And I would like to dive deeper into the concept of data product because this is one thing. If we said earlier we want to make data reliable in AI, it is important that we treat data really importantly because we all know that the AI is only as good as the data underlying data is. So the quality of the data has a clear impact on the quality of AI responses. That's one thing, and there's one additional sentence that I will come up with later with you because it's not only about data quality. That's one major part, but that's probably not actually the most important part. But keep this for later. So, a data product. So, a data product basically consists of multiple parts. As I said earlier, you have in the center is data storage, and you have on the left side you have input ports, and on the right side output ports, and the top is the discovery port. So, an input port is basically any kind of data lineage that you want to trace. What is the source and the sink is the data product. That's neat for data lineage, and it can have multiple ETL or ELT jobs. Then it's stored again individually in a local database and it has clear defined ownership. It is transparent. What is the transformation code? You have long test suites with it. You have documentation. You have cost management. You have policies that will be applied on top of the data product. You have CI/CD pipelines for the data product. So data products are not done manually. They're again like software products. They are some sort of like a kind of a microservice. Um, so it's one of the artifacts of either microservice or data products. And then there's an observability rules again. So Discovery Portal helps you to, um, even so the data product still resides in the business unit, the Discovery ports ensures that all the required information that needs to be for the marketplace will be visible on the marketplace. And the output port is basically consumers will attach to the output port and read the data from the place as they would like to read it. So you can have maybe one output port could be a REST interface, one could be a view, a JDBC-based view on the data that has a subset of the data because it's anonymizing or hiding fields. And so it's basically you have multiple consumers in it, and you can, based on some consumer needs, you can build new output ports, but it's still on the same data. And they all, of course, follow the FAIR principles. So, and when I said basically data quality is for AI really important, there's one thing which is even more important, and that is semantics and context. So the AI agent is only as good as the context and the data quality is. So please keep in mind semantics is pretty crucial. And to give you one example here, keep that in mind is basically you have you living in the future and there are multi agents running around and every business unit has its own agent doing something. And there is one agent is like, I want to get information about the account. And then if you're not clearly define what the account means, there might be an agent from the system side that is responsible for managing accounts on the server side. That's okay. But if the person had in mind, I'm looking for an account in the banking context, and it's like, oh no, the account should know my salary or my current balance. So this is the context. And and this is why I'm heading over to Inga because she is the knowledge engineer here in adorsys, or one of the knowledge engineers in adorsys. and she can explain this pretty well. I hope your bandwidth is stable enough, Inga. If not, just let me know.
I just, here I am, but I will turn my camera off because the internet connection here is a bit unstable. But as you said, it's all about context, and you can click on the next slide. So what he was talking, if we imagine we have different kind of agents to specific, different kind of domains, and everyone or every agent does say anything else. So if you click just like this flow, right, and every agent says something differently. Why is that so? Every data product, for example, has a different kind of meaning about customer. So if you click through the slides, you will see that customer in sales is completely differently to a customer in finance or in customer support. And if we look more into detail into the description of finance, for example, you can click to the next slide. And for me, as a, I would say, a developer or someone who looks into the data product, you look at this description and say, okay, a customer is someone who has made a financial transaction, for example. So a financial transaction is something that I think what it actually is, but I don't know exactly the exact meaning. The same is for an ERP system. So maybe I know what an ERP system means, but I'm not 100% sure. If I want to look more into detail into financial transaction, I have to look more into deep into the data. And also for the agent, it's a bit complicated, I would say. So if we break it down, how could we describe it a bit more precise so an agent or a system can understand it a little bit more, or we also can understand it a little bit more, especially if we want to go to understand the relation between those different kind of entities. So for example, we have the entity customer. Okay, now you can click a customer. Nice. Okay, we have a customer, and the customer makes a financial transaction. So how can we show it? Like with, yeah, I would say it's more easy like a mind map, or how we call it, a graph. And a customer is also registered in an ERP system. So the main advantage out of this ontology, so this is something, a buzzword, not only semantics, but an ontology, how we describe it, is more precise, and we can look like really easy what kind of relationship a customer actually has. And one thing that is also an advantage, you can actually add some other relationships to a customer. So if we go further and look into the other descriptions that we already have for customer, for I think sales it was, and if we have descriptions for a customer and support, there you can see, okay, a customer is like our main goal or our main yeah,
Entity.
entity or property or anything else. But the main advantage out of here, you can see transparency. Everyone can see that sales and finance customer actually in their domain itself means something differently. You can see they are actually connected. So system can actually prove if an entity actually fulfills specific criteria. Then also, especially for an AI, can actually automatically detect if a data set is a sales customer or a finance customer. And one thing that is really, really important, it's the governance. The governance about this, if you click further, instead that every domain needs to argument to each other which customer is the actual right customer. An ontology helps that everyone or a customer from sales, finance, and supports are the right customer in their own context or in their different domains. So this is pretty nice, right? So in their own domain, they have their relationships and their description for their business or their like ubiquitous language, for example. But if we go further, if we go into, if we want to answer more critical business questions, for example, if we want to completed with strategy, and then we go from a context to finance to sales, purchasing, merchant acquisition, compliance, and everything on. So these questions are actually connected. And why don't we actually connect our business or our business knowledge with other business knowledge, especially if we want to ask questions throughout domains? So that means we go from a data product. You can go to the next slide. We go from a normal data product to an actual semantic data product. So that if we have different ontology or different graphs together from different kind of domains, there we get a more knowledge, and we can combine all those different contexts, and an AI or an agent can actually understand also a little bit more how those different kind, you can go, maybe you can see it then better. You can
Yeah.
actually see how the connections are really throughout the organization. And especially, as you said, if you want to rely on different kind of data, or if you want to, um, I would say, you have your rules in your company, right? And you want to make it clear also for an agent. This could be a possible solution how to deal with it. And I think Tim can say how we can actually implement, or what steps are needed to do to produce those semantic products, for example. So I hope.
Thank you. Good to have you on the show because I could have explained it better than you. And it's so then let me take over. I promised earlier I will bring a blueprint with me. So that's basically the framework. The blueprint is, well, how can we then bring the data from basically from data products to information products? Because data mesh initially is the idea of, well, slicing the world down into smaller silos. And I've implemented data mesh in the past in different organizations. And I discovered over time that, yeah, then you have smaller silos and still you don't know how to get from A to B. And my computer spins around. Um, so, and this semantic layer, as Inga described, this graph on top of that helps people to understand how data is interoperable with each other, and also agents will understand it. So, how to do so? Basically, what we recommend usually is we go in like doing, well, one single use case is like get a subject matter expert and a knowledge engineer into one room. Let the business expert describe in their business language what they are doing, what is the process, what are the entities they're working on. Like this simple example with the customer side. And you get a graph out of this. And this graph then can be added into a bigger organizational graph. And over time, these graphs will get more nodes and more edges. And you have seen it in the earlier example, like there was an overlap already on the customer side. And there are so many multiple entities in the organization, which are the single hotspots, basically, which help you to connect a lot of entities in your organization. And over time, you get a big, big graph here. And now you have the graph, the abstract knowledge, how the implicit knowledge how the company works and how it should be worked together. So basically what you have to do is basically take your data sources, your data products, take your data engineers, run those data products through the knowledge graph and basically map the fields. Basically, this field of your columnar table shows the customer. This has probably the the financial transaction. This has this, and then you basically map it out. There are tools, and AI can be your friend to do the mapping for you because AI is pretty well understanding how things map to each other. But building a knowledge graph is something that I strongly recommend doing with humans for you because if you AI let go circling here, that never turns out pretty well. So once you have run the data product through the graph, you get an information product. And if you have the information pyramid probably in mind, if you don't know that, Google information pyramid, there's basically data and then there's information. And you get from data to information by adding semantics. And that's what we have just have done. So you get one level up into the information pyramid. And the next level is basically then knowledge. And this is basically when the AI kicks in, basically, the AI agents can operate pretty well on these graphs. They understand graphs so well. You cannot imagine like how powerful LLMs can be if you give them a graph and a context. The answers you will receive from that graph is, I would say, it follows your terminology, it follows your concepts. It is so strong. And then in the end, still having the same concept of data mesh, its central marketplace, central data platforms so that consumers can consume the information product quite easy. So this is the blueprint. And we're a bit over time. Just to give you the final slide here is, well, this was a blueprint. Now, how we do it basically, as I said, take the knowledge expert and the business unit, model the graph, take the knowledge engineer, the data engineers, and identify potential graphs, then have some AI in the middle with human in the loop concepts, do the mapping for you. This can be done also with business people that you do some reinforcement learning, that you get a quite appropriate mapping here. Then derive out of this mapping pipelines where you basically map the columns to the knowledge graph entities. Then you have data product, as I said, then basically add this to the marketplace and other people could, consumers could request access on it. And the owner of the data product, then again have data mesh roles and processes again in there, uh, are in charge of granting access. And this is basically the blueprint in a really simple slides. And yeah, it's a bit slightly over time. Sorry for this. And yeah, with this, I hope you liked it. If you have questions, feel free to scan the QR codes. You're gonna find Inga's and my LinkedIn profiles. We frequently posting about this topic. And if you want to chat with us about it, just ping us. And thanks for having us.
Thanks, guys.
Bye.
Bye bye.
Yeah.